So if you watch the Math 120-10 video from yesterday, I go through the whole test because I have an hour and a half, and it went a whole lot faster because I was not using the calculator with this mouse, or I might have been. I can't remember why we were just going to look. Oh, I skipped all the bonus questions. That's for one thing. And I was able to cover all the questions in an hour and a half. And we went over about 10 minutes. So if you want to watch the whole test in its entirety, one video, then watch the 120-10 test or video from yesterday. So let's get started. Let's go to the, y'all should be able to see my screen up here. So let's go to y'all's class. Let me know if you can't see the screen. And I hope there's not a lag. I'm going to click on Course Tools and Assignment Manager. And I think y'all's test is due today, is it not, or tomorrow? When is it due? The 10th. All right. And preview. Now, I'll try to remember what we did cover, but y'all are going to have to help me because since I did Math 120-10 yesterday, I may get y'all mixed up with them, and I can't remember. Did we do this question? I don't think we did this question.
No, we didn't do that.
Yeah, this is comparing the two. So you're going to draw two curves. I'm gonna let y'all read the question while I'm going to draw two curves, and you're going to have to draw two curves also. Y'all printed out them curves yet, or y'all still drawing them? No, I ain't gonna say. 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, and 0.15. And then I'm gonna do another one in another color. Zero, 1, 2, 3, -1, -2, -3. And I'm not going to do those percentages again because I got to. Now, the question says, I'm going to turn off my video. Maybe that'll help with the bandwidth. Okay, it says there are two college entrance exams that are often taken by students. Exam A, and I'll just call this top. Let's see if I can get the video. There we go. There we go. Let me move this down a little bit. Okay. Y'all see that okay? Now, Miss Coalition and Mr. Brooks, y'all going to have to do the talking now. All right.
Yeah.
Thank you. All right. So we're going to call this one. I done lost my pen. What did I do with the pen that I just drew this with? Oh my gosh. How did I lose a pen? Okay. All right, this is A. And this is B. Okay, it says exam A is normally distributed 20.2. And I'm sorry, I'm going to use 20 and 5. 4.7. I'm going to use 20 and 5. So this will be 25. This will be 30. This will be 35. This will be 15, 10, and 5. Okay, you're not supposed to do that, but I'm doing it because I'm not going to sit here and try to do those decimals in my head. The bottom is 1210. No, 1018 and a standard deviation of 206. 1018 and a standard deviation of 206. Why do they do these crazy numbers? All right, so I'm going to let y'all do that. I'm going to have to do it. Just hold on. Oh, why can't they just do even numbers? Especially on a test. Calculator. 1018, 206. 1018 plus 206. That's 1224. I hope, let me move this up a little bit. I don't know if y'all can see it. Well, let's write down, suppose you scored 27 on the first one. And you score a 1210 on exam B. Okay, now I can get rid of that. All right, so hopefully y'all can see what I'm doing here. 1224 plus 206, 1430 plus 206, 1636. And go back the other way, 1018 minus 206, 812 minus 206, 606, and minus 206, 400. Okay, so there's our two curves. I'm going to bring it up a little bit. There we go. Now I'm going to take the A and I'm going to plot A. I'm going to plot it in orange. 27. 27, well that's halfway between, so it's right there. So 27 is also a z-score around 2.5 or 1.5. This is around, and this is around as far as graphing. I just graphed it right there. All right, so that don't look orange, but it is
Priority
orange.
1 message coming in on secured channel.
And that would be
Priority 1 message coming
what
in on
in the
secured
heck?
channel.
All right, sorry about that. And then this one is 1210, and 1210 is going to fall, I'm not even going to try to estimate it. 1210, I'm just going to put 1210 right here, and looks like to me that's around 0.1 or 0.8, 0.8ish. So I can tell you right now that this score is going to be higher, but we'll go ahead and do it. So you want to change this one. If you got an older calculator, you want to change this one into a z-score. So that's going to be 27 minus 20.2 divided by 4.7? Hold on just a minute. I'm going to mute myself a minute, okay? Trying to talk to my son. There he is. Hold on. Okay, I'm sorry. So let's change 1210 into a z-score. Somebody change this into a z-score for me. 1210 minus 1018 divided by 206. Somebody give me the orange. What is the orange? I'll do it.
I got 1.49.
Thank you. I said 1.5, 1.49. Now, I'm not bragging on myself when I do that, y'all. I don't want you to think I am. What I'm trying to show you is you can do a lot with the empirical rule, and you can already say that this score up here is going to be much higher than this score because of the z-scores. All right, somebody give me the green z-score. What do you get? I'd say 0.8, 0.75. What'd you get?
0.93.
Okay, 0.93. Now, I want y'all, with your calculators, what was that? Okay, she got 93. Okay, my computer was making a noise. All right, so whatever calculator you have, I want you to find the orange area and the green area. Find the orange area and the green area. I'm going to take my handy dandy calculator and I'm going to pull up. I'm going to move this over here and bring up my calculator. And since I'm going with old calculators, just in case people have old calculators, I'm going to go second, bars, normal CDF, and negative 9999 to 1.49. Because if I have an older calculator, I can't change the mean and the standard deviation. So enter and enter. I got 93. So that's like a 93. I'm going to write 0.93 in orange. 0.9319. 0.9319, which means he made a 93 on the test. He's in the 93rd percentile. Okay, now let's do second entry. And I'm going to back this up. And I'm going to type in 0.93. Now the reason I'm typing in 0 is so I don't have to mess up the place values of my previous entry. Enter. And that gives me an 8.8238. 0.8238, which is an 82. Now it doesn't take a rocket scientist to know that the grade on A is a whole lot better than the grade on B. So let's read the question and see what it asks. The score on exam A is better because the percentile is higher. I'm sorry, my eye's itching. Yay, we're smart. All right, questions on that one? All right, next one. That's probably, I'll go ahead and tell you right now, mark that question right there. That's probably the most difficult and longest question on the test. I went through the test yesterday with 110 or 120-10, and I think that was the only one that we had to spend more than 2 or 3 minutes on. All right, draw a curve. Now, I'm not covering, there's about 3 or 4 on a test like this. I'm not going to cover all of them because they're repetitive. But what we will do is do one time, and then y'all can do the others on your own. Okay, Miss Carver sent something, but I can't. Hold on a second. Well, oh, there it is. We did one like that yesterday. Okay, good. Then we'll move on then. Thank you, Miss Carver. I can depend on Miss Carver. The rest of y'all suck. Just kidding. Just kidding. All right, so, but let me ask you this. When you see between, you know it's going to be this one. I mean, if you can't tell that that's between, and this is not between, and this is not between, don't tell anybody. That's between. X is between two numbers. So you should at least get that one right. All right, next. Miss Carver, you keep a count on what we did and make sure that we don't cover the same one, because I want to make sure I cover. Okay, I think we did this one. Check and see. This is the one where we had the, yeah, we did that one. That was one of the first ones we did. Right, Miss Carver? Yes.
Yeah, we did that one.
Okay. Ooh, I don't remember seeing this one. Oh my gosh. Is that all? This question should be taken off. What is mu? 530. What is the standard deviation? What? 3? Yep. Miss Carver, you need to get your daggone microphone fixed. All right, next. I don't think we did one of these. I did. I think I skipped these in the 12010. So to make it fair, I'll do one of these for y'all, because you're going to have to, now you're going to have to, I'm going to try to do it on one graph because it's 4 questions and I'm going to use different colors. So go ahead and draw a big graph. Draw a big graph. And I'm going to do the base graph. I'm going to do it in black, even though I've got a bunch of dead black markers. I've got to get markers today. I'm not going to put the percentages on here. 0, 1, 2, 3, -1, -2, -3. Okay, there's the base graph. So I'm going to put my black markers away. And we're going to do the, let's look at the mean and the standard deviation. 264, so I'm going to do that in black also. I'll move it up in just a second. 264 plus 20 is 284, 304, and 324. 264 minus 20 is 244, 224, and 204. Please check my math. Make sure I ain't crazy. All right, so I'm going to move this up as soon as we write down what we need. I'm going to write down in different colors what we need. Okay, more than 274. We're going to do that in blue. More than 274. We'll do that in blue. Orange, we're going to do 239 and 279. 239 and 279. That X is in the middle. That means between. No more than. Well, no more than means up to 234, doesn't it? No more than 234, so that means up to 234. So I'll do that in pink. Up to 234. And the last one we'll do in a purple. Less than 219. All right, so the first one is in blue. 274. Well, I'm going to say 274 is right here in the half. More than 274. Now, I know that this is 50%. So 50%, I got to move this. I'm going to make it big. There we go. I know that this is 50%. So 50% and half of this, because 264 to 284, 274 would be right here. So half of 34 is 17. So 17 from is 33%. So I'm saying by the empirical rule, we're talking close to 33%. But I've got to change that. I've got to change that 274 for an old calculator. I got to change that 274 minus 264 over 20. 10 over 20 is 0.5, which I knew that when we drew it on there. So somebody, I need one of y'all to take your calculator and give me from normal CDF from 0.5 to 9999. I know it's going to be around 33%, but go ahead and give me that number. 4 digits, please.
I got 0.3085.
3085. I would say that's correct, but I'll be glad to ask somebody to confirm that if you've got a calculator. So that's that one, 0.3085. Now we're going to do the green, Verde. Okay, I got the same thing, good. All right, 239. 239, let's see. All right, so this right here would be 234. So 234, that's 10. That'd be 230. That'd be 239 right here. So 239 be 1.25, negative 1.25 around. Okay, and we know that 4 into 13 is 3. So that's going to be 3% right here. I'm doing the empirical rule as I plot it so I can make sure when I get the answer that I'm pretty much in the ballpark. And 279, well, 279, we know that this is 274. Half would be 279, so that's going to be 0.75. And that's a fourth of, this is a fourth of, I'm thinking out loud, a fourth of 34. 34 divided by 4 is 8. So that's 8% subtracted. So this is 34, and 34 minus 8 is 26. Oh, shoot. 24, I think. I can't remember. 34, no, 26. So 26, that's 50%. 63%. I'm going to come up with 0.6300. That's what I'm thinking, but I could be wrong there because I did some subtraction in my head, and I'm not good with subtraction in my head. So 234 or 239, we're going to change that into a z-score. So 239 minus 264. Somebody do this for me. Divided by 20. What do you get?
That's your negative 1.25.
Good. Okay. And somebody give me, I'm looking, yep, she got 1.25. And then somebody do, I don't forgot, 279 minus 264 over 20. What do you get? .75. So somebody take your calculator and go from normal CDF from negative 1.25 to 0.75 and give me 4 digits. I said it was going to be 63%. 6677, is that what you got? I'm looking on this. My glasses come today. I ordered new glasses, so I'm going to be styling and profiling tomorrow. 0.6677. So that's your answer there. Now let's move to the peach. Peach is up to 234. Up to 234. Well, I said that 234 was at negative 1.5. But 234 minus 264, yep, 30 over 20 is 1.5, isn't it? So I'm going to say half of 13.5 is 7. Okay, so that's, I'm going to say 6.5. 6.5 and 2.5 is, I'm going to say this area right here, I'm going to say it's around 9.0900. Somebody do 9999 negative 9999 to negative 1.5. Somebody give me 4 digits. 0668. Is that what you said? 0668. And I think the reason I'm off is because I said 6.5 here, and it might be 6.75. That's probably why I'm a little bit off. Okay? All right, so that's that one. And then less than 219. Less than 219. Well, we know this is 10. This would be 214. 219 would be in the middle. So we're talking less than 2.5%, maybe 2% or 0.18, but let's change it. I ain't got any room. So we're going to do up here in the corner, we're going to do 219 minus 264 over 20. Somebody give me that z-score. Negative 2.25.
Yeah, that's right.
And somebody do 9999 negative to 2.35. Okay. 0.0122. 0.0122. Now, I know that's a lot of cumbersome, but that's why I did it in colors, and that's also why you need to make sure you have a bunch of graphs drawn, because it'd been a whole lot easier, better to do this on 4 graphs. I'm just going to show the answer, because I'm not going to type those in. So let's just hit show completed. Okay, there we go. 0.0401. Did we get that? I don't see 0.0401. Lasts more than 306 days. Where's 306? Is that the same numbers we had?
No, it's not.
Well, why did it do that? Okay. I don't know why it changed the numbers. Okay, well, I know I'm right, but anyway, we'll keep going. I don't know why it changed the numbers like that. Assume that the random variable is distributed with a mean of 50 and a standard deviation. Find the 24th percentile. Okay, I'm going to go over this question because I had somebody email me the question like this, or not email me, but text me, and they said they were a little bit confused about the percentile. Well, you shouldn't be confused because I told you at the beginning of 6 and 7, we're going to write this in red after I get the board up. What did I tell you meant the same thing in this section? Percent, area, and probability. Remember me telling y'all that all those is equal to area under the what? Cov. Area over the coven. Okay, so we're going to have witches. Isn't that a bunch of witches? Coven. Oh, shut up, Hubert. I can't even remember what I was writing. Curve. C-U-R-V-E. Area under the curve. So, if I give you a curve, the area under that curve can be called a percentage, it can be called an area, or it can be called probability. Do y'all remember me telling y'all that? Okay, so this is saying, okay, I hope you did. Yeah, okay. So this question right here, I'm going to show you, there's 2 questions on the test like this. And I don't know if I remember doing this with y'all, but I did it with the 12010 class, and I got somebody texting me from one of the classes saying, how do we do a percentile? Well, percentile is area. So you change that 24, you change that into 0.2400. Okay, so now, and you can do your 50, this is 50, this is 16, so that'd be 66. 66 plus 16 is 82. Y'all help me out here. 82 plus 16 is 98. 50 minus 16 is 34. 34 minus 16 is 18. 18 minus 16 is 2. Please check those numbers. Okay, so where is 24%? Well, this is 50%. Y'all know that. So this is 50 minus 34, which is 16%. So at this point, that's 16%. So let's do half of 16 to 50 would be what? 34%, right? So half of 34 is 17. 17 added to, that's 33 right there, isn't it? Okay, so I'm thinking out loud. 7, 8, 9, 10, 11, 12, 13, yeah. So that we know that's halfway through. And again, I'm using my empirical rule before I do anything. All right, half of 17 is 8. 8 plus 16 is 24. So that's 24%. They're wanting what? So I would say that 24% is falling right in here. Now, by the empirical rule, I would suggest that is at negative point, let's see, 4, that'd be 0.75, negative 0.75. And I would say that the test score is going to be, well, if this is, what do we say, 16? Then that's 4. Each one of these is 4. 4 times 3 is 12. or we just add 4 here, that'd be 38. So by the empirical rule, I'm going to do that in black. By the empirical rule, I'm saying that we're talking about the 24th percentile falling, and we read from left to right. So it always reads from left to right, unless you say right tail, it's left. That 24% is going to fall right in here. Now all that's done with the empirical rule, so that's in black. Now we're going to actually find out with peach. So I've got an area, and I need a z-score. If I've got an area and I need a z-score, I use inverse norm. So I'm going to type in second vars inverse norm and 0.2400. Now you don't have to type in 0.2400. I type in 4 digits because I'm trying to relate to students that 4 digits is area. So I need somebody to give me that z-score. I said it was going to be around 0.75, but we need the detail. So what is it? Somebody do it for me. Second vars, inverse norm, 0.2400, close parentheses. Well, I guess I need to do it. Second, I knew it just as soon as I pulled up the calculator. Second vars, I appreciate you doing that, Miss Carver. Second vars, 0.2400. And which tail? We got to put in, well, I'm going the old school. If you have a new calculator, you would type in the mean and the standard deviation, and it would give you the test score. We don't need the test score. We need I'm doing the old calculator, so you can't change 0 and 1. Left and enter. So that gives me a z-score of negative 0.71. So I was off a little bit. So this is our z-score of negative 0.71. So that's our z-score at 24%. Now we have to use x is equal to oz plus mu. X is equal to oz plus mu. So x is equal to 20 times negative 0.71 plus 50. So 20 times negative 0.71 plus 50. Now, by my empirical rule, I said it's 38. It came up with 36. So the answer is 36.
Hi there. It's currently 10:55 a.m.
Now, if you have a new calculator and you could type in the mean and the standard deviation, then it would spit out 36. I think that's what you got. Okay, you got 38? Let's see what the answer is.
That's what I got too.
Well, I must have done something wrong. Where's the question? Okay, I must have done something wrong. I might have, let's see. I done something wrong. Somebody needs to check my, did y'all get a z-score of 0.7? Oh, I didn't leave the digits in there. That's what it was. I should leave those digits in there and I didn't. That's why. Okay, so leave the digits in there. My bad. Next. Next. I think we've covered everything. Did we do a uniform? I think we did a uniform, didn't we? Yes, I thought we did. And I covered that also in the 12010. Okay, this is area between zero. If you've got an old calculator, then all you have to type in is 1 and 2. That's it. You don't have to even draw the curve. Just type in 1, lower bound 1, upper bound 2. Since it's z-scores, you know that the mean is 0 and the standard deviation is 1. I showed y'all that the first part of chapter 7. Find the sum of the areas under the normal curve to the left of, okay, this, you could do it two ways. You could find 1, negative 9999 to negative 1.25 and multiply it by 2 because these two are symmetrical. Okay? Or you could multiply, you could take 1.25 on the lower bound and go to 9999, multiply that by 2 because it's symmetrical. Or you could do from negative 1.25 to 1.25 and subtract that from 100 or 1, and that would give you the same answer. There's several ways to do this problem, and I'm going to let you decide how to do it because there's several ways to do it. Same thing as the previous problem. You just, if you've got an old calculator, then you're set to go. If you got a new calculator, then you would set the mean to 0 and the standard deviation to 1. And then you would just type whichever one you wanted. Suppose that a recent poll, blah, 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 blah. This is, did we cover this? NP and MPQ. I don't think we did in this class. But I did in the 12010, but I'll do it right quick because it's simple math. Did we do this one?
I don't think so.
I don't think we did. All right, so here we go. I don't think so. This is the problem where you don't know. This is what students, how do you know when to do what? Read the directions. All right, it says they want the mean and the what? Standard deviation. They want the mean and the standard deviation. I'm writing. And they only give you N and P. Okay, they only give you N and P. So therefore, you're going to use mean is equal to N, P, and standard deviation is equal to the square root of NPQ. So take your calculator. Oh my gosh. If you use your calculator on this one, I'm not going to speak to you. Mean is equal to 200 times 0.5. Mu is equal to 100. Oh my gosh, this is so easy. Standard deviation is equal to 100, that's NP, right there, times 0.5. Oh my gosh. What's half of 100? 50. And the square root of 50, whatever that comes out, that'd be what, 7.1? Because 49 is 7. So that should be your answer. And remember those The mean is the number that would be what? Expected. Make sure you remember expected, that the overall state of moral values is poor. Expected to believe, when you see expected to believe, that's a joke. Mark that out. That's expected to believe. Expected to believe. Expected to believe. Well, they have it in this one too. I'm sorry. I'm looking to see what the difference is. The mean is the number. A mean is a number. It's not a range. It's not a maximum. It's not a minimum. It's just a number. So that's the giveaway right there. Would it be unusual? Well, what do? You draw a curve. When you look at unusual, you draw a curve. Mean is 100, 107, 114, 121, 93. I have no idea. 93 minus 7 is 86. Hell, I don't know. And 86 minus 7 is 79. All right, plot the point. What do they want? 102. Let's plot 102. Where is 102? Is that normal? Well, is it in the 2 standard deviations? Yes. 2 standard deviations is what? Normal. So 102 is normal. Would it be unusual? No, because normal means not unusual. Okay? Question on that one? I'm trying to hurry. I know y'all, let's see, what time is it? I don't have anywhere to go, but some of y'all. Find the z-score. Okay, this is inverse norm. I'm going to do this one. I mean, you don't have to, just do inverse norm. Do inverse norm 0.04. Somebody do that. And it's going to be, what does it say? What's the area to the what? To the left. If you've got an old calculator, it's going to default that. If you've got a new calculator, you want to hit left tail and put in 0.0400 inverse norm. And tell me what you get. Should get negative 1.75. There she goes. Negative 1.75. So that's another gimme. That's an easy question. Follows a normal distribution, 600 with a standard deviation of 50. Draw a curve, falls below 450. So you're going to find the area. Draw a curve, 600, 650, 700, 750, 600, 550, 500, 450. So 450 is going to be very small. And that's where that comes out to be. Okay, we did one like this one. I'm not even going to, it's between again, let's see, between 54 and 69. Would be this one right here. Okay, greater than. If you have a new calculator, you would say right tail, because X is what? Greater than 94. If you have an old calculator, you would type 94 minus 90 is 4. 4 divided by 5 is 0.8. So you would do from 0.8 to 9999. We did one like this one. You always look for negatives, and then you add them up. 2, 4, 6, 8. That looks pretty close to 1. That's another gimme. You got 3 gimme questions along with the bonus questions. Everybody should make like a 45 on this test. NPX, binomial. Now this is exact. All right, remember, exact. And I know I went over this in class, but I'm going to go over it again. Exact means equals, which means binomial, what? PDF. And I tell students PDF stands for precise. I don't even know how to spell precise. Okay? Up to, which means less than, is binomial CDF, and the C means cumulative. So that would be like 0, 1, 2, 3, 4, 5, at most 4, or not at most. I can't remember right now. Less than, okay, X less than 4. So that would be cumulative. You would type in N, P, and then you would type in 3 because you want 0, 1, 2, and 3, not including 4 because this does not have an equal sign below it. So remember, so in this case, this is exact because you see the equal sign right here. You would type in binomial, and you would type in 50.97 and 48. Next question. I'm waiting. Okay, this one, the mean incubation, this is nothing but empirical rule, or it was z-scores. But what students do is they get confused in all the weeds, all the writing. Draw a curve. It says mean standard deviation. Mean is 25, 27, 29, 31, 23, 21, 19, and then do your z-scores accordingly. Okay? And I guess it looks like, okay, that right there. And then find the, okay, find the probability. Find the area under the curve. Find the percentage. Okay? And NP, okay, this is the one I just showed you. I just showed you this one. Well, I'm darned. Well, yeah, that one's equal sign. So that would be this right here. Oh, sorry. Okay, notice it was X is less than 4. X is less than 4 is the same as X is less than or equal to what? 3. Those two are the same because this one is not inclusive of 4 and this is not equal to 4. So these are the same. You would use cumulative MP3. And that's it. Find the z-score having the area 0.86 to the what? To the right. So that would be, if you have a new calculator, that would be inverse norm 0.8600 and right tail. If it asks for right tail. Oops, sorry. Okay, if it doesn't ask for right tail, you do inverse norm to 0.86. If you got an old calculator, inverse norm to 0.8600, and that'll give you the area to the left. Okay, or it'll give you the number. Yeah, it'll give you the z-score. I'm sorry. I'm thinking of something different. You don't have to use right tail. Okay, you just need the z-score. I'm thinking of something different. So inverse norm 0.86. Somebody do that. What do you get? It should be negative 1.08.
Yeah, that's what I got.
Okay. All right. That's it. So now you can watch this video, and you can watch the 12010 video, and you can get double the review if you need it. Of course, some people need it, but they won't do it. But that's just the way things are. Y'all got questions for me? Now, what will we be doing the next couple of weeks? We're going to finish out with chapter 8, 9, and 10, as far as I can get. We'll go up to the last day of class, which will y'all be the 20th. If I cover up to, let's say I cover up to 9.2 on the last day of class, then that last test will start on the last day of class, and it will go until the final exam date. Okay? So, whatever I cover up until the 20th will be on your last test. It'll be called the Unit 4 test, and it'll say last exam, and then the final exam. The last test and the final exam will start on the 20th and end on the last day of exams. And I can't remember what day is the last day of exams. If you know, I would appreciate it if you could spit it out. I can't remember. Let's look and see. Main menu, academic calendar. And I'll go over this more. I mean, we got like 2 weeks. Last day of class, last exam, 28th. So you'll have from the 20th to the 28th to do the last test and the final exam. And once you finish the last test and the final exam, you'll be good to go. That's it. Whatever the grade book puts out, that's what your grade is. Questions, gripes, complaints? Then we will start new material come Friday. Y'all have a good day if y'all don't have any questions. Okay, I'm going to stop the